Welcome back, everyone. Today we'll be discussing basic science for the respiratory therapist. Part 1 is matter and heat transfer. Alright, well, we're going to open with states of matter. This is something you probably remember from all the way back in your basic chemistry classes, but just a little bit of a refresher there. We have our states of matter. We have solid, liquid, gases, and plasma. Depending on who you talk to, there may be a few other ones listed there, but those are the 4 basic ones that you need to be familiar with. Okay, and our first topic today is the first law of thermodynamics, which states you do not talk about the first law of thermodynamics is the law of conservation of energy that states that energy cannot be created nor destroyed, only transferred. So thermodynamics is an interesting branch of the physics that deals with the relationships between heat and other forms of energy. And our first law, again, is the principle of conservation of energy that states that the total energy in a system, in an isolated system, is constant. Energy can be transformed from one form to another, but it cannot be created, it cannot be destroyed. It can only be transferred. So if you have a certain amount of heat or work in a system, it's always going to have that certain amount of heat or work. It can't be increased or decreased. It can only be a balanced system. And this is the relationship between work and heat will always be equivalent to each other. So forms of heat transfer. This is when Miami transferred LeBron James back to Cleveland. No, actually, it's a couple forms here. We have conduction, convection, radiation, evaporation, and condensation. It's a mouthful. So conduction is heat transfer that occurs with direct contact. So objects that in this system have to be touching. And remember that the hotter object always will pass heat to the cooler object. So we have a picture here of a baby, and we're going to assume that he's on a cold bed. So the heat from the baby is going to be transferring into the cold blanket or bed or whatever he's laying on, and that's going to result in the baby losing temperature and potentially getting cold. So next up is convection, and convection is how heat passes through fluids. And this is a fluid is anything that has loosely moving molecules that can move easily from one place to another. And this includes everything with your liquids and gases. They're fluids, and the respiratory therapist is going to be working a lot with these fluids throughout their entire career. Another important thing to remember about your fluids is when you're on Earth, because of gravity, heat will rise and the cold will sink, or the cold sinks and heat will be on top, depending on how you want to look at it. And that's because the molecules will spread out as they get hot. Hot fluid becomes less dense, and that causes it to rise, and the cold air becomes more dense, which causes it to sink. And these up-down currents actually create currents. And the currents are considered the circular movements of heated fluids, and that can help spread out heat. So here we have a picture. So this is our baby that is getting cold because of convection. And this is somebody left the door open, and the cold air is blowing in, and the baby's getting cold from being close to that source. Okay, radiation is another form of our heat transfer, and this occurs when heat moves through an area without direct contact. So this is what we see when you're ever at one of those fancy dinners and they have the chef sitting there with the giant delicious ham, or you might be at a delivery and you'll see a baby. They always put them underneath that warmer table, which is cleverly called the radiant warmer table because it heats by radiation. So you have your heater source. It's not touching the baby. There's no air fluid currents or anything like that that's warming up the baby. It's just the heat from one object's transferring to the other, but there's no contact. And finally is evaporation, and this is when the process when heat undergoes a phase change from a liquid to a gas. And evaporation from a liquid surface is an efficient cooling mechanism, especially when your goal is cooling. So this is when you sweat, is your body's natural evolutionary way of cooling yourself. Is you perspire, you get some water on the surface of your skin. That water then is evaporated, and that creates a cooling effect on for your body. So as it relates to kind of the newborn, that's where I know most of this stuff. Is when you have a baby born, your first things that you're going to do for NRP are dry, warm, stim. And it begins with drying, because if you have a baby that's covered in cold, even warm birth fluid, eventually it's going to cool pretty quickly. So this can cause a baby to get cold, and then you're going to have cold stress and all these other problems. knows that could happen in an infant. So the first thing we always do is dry. Then we have our heaters already gone, so we start warming them up, and we get them ready to transition to maintaining their own, normal thermo-regulated environment.